Okay, so we're just going to do a brief introduction of trigonometry. There's some symbols that we need to recognize before we start. Okay, so this first symbol, it kind of looks like the Pepsi symbol. Does anybody know what that one's called? Yeah, good. So that's a Greek letter, and it's pronounced theta. Okay, make the screen bigger, just a tad. Is that better? A lot better. Okay, so theta is what we're going to use for angles. We're going to use that for the symbol for angles. Okay. Use for angles. Now these next couple symbols, like I use this one with the squiggle. I'll use this one to approximate. So I'm not sure exactly what they use that for in geometry. Now the next one, this is like congruent. I don't know if you remember that. So it's like two shapes are congruent. They're exactly the same. I believe that's a geometry symbol. Now we're not going to be using those two symbols very often, so don't worry about them too much. This one's obvious, not equal, and we're not going to be using that very often. The two that I really want to emphasize is this one, so like angle ABC. Okay, this symbol means angle, and then ABC, it would be like this. Here's the angle, say it's like 30 degrees or something. The way you write it, and I'll highlight it for you, is the angle at the vertex is in the middle. That's crucial for your success, okay? Because sometimes they will give you a word problem where it says angle ABC is 30 degrees and then blah 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 blah. They'll keep going on. They won't give you a picture. So you'll need to know where the angle in the shape exists, okay? So the middle letter is the vertex, okay? The middle letter is the vertex. And similarly is the next shape. This means triangle. It's the what I just said with angle, it's identical, okay? So triangle ABC, and I'm just writing all over the page. You write wherever it's necessary. Triangle ABC would look like this. ABC. Okay? And then, like, it doesn't matter where the vertex is for this triangle ABC. You don't know. The one that's crucial is this. Angle ABC. That's the most important one. Angle ABC. So you know where the vertex is. And then the next one, like, I don't even know what you'd use that for. I can't remember. And it's not that important. Okay? So what is important for this upcoming chapter is this one right here. Angle ABC. This is the most crucial one. And if you know theta and angle ABC, you'll be good. And it could be anything. X, Y, Z, PQR, whatever. Okay? I'm going to erase everything on this page. Just let me know when that's okay. Can I erase everything? Okay. Okay, the next thing is angle properties. So for opposite angles, that's when you have two lines crossing each other like this. So those two angles are equal, and these two angles are equal. So let me just use some color to help you out. Oh, that didn't work. Okay, let's use the pen. So this angle and this angle are vertically opposite. That means they're straight across from each other and they're equal. And then these two angles in green are vertically opposite and equal to each other. The next thing is parallel lines. So when you have parallel lines like this, and then you cross with a transversal, I don't know if you guys have heard this word before, transversal. What ends up happening is you have a group of angles that correspond to each other. Okay? So this angle here, in the top left, where does it correspond? Yeah, those two are vertically opposite, right? So they're the same? Yeah. Now, it's like a neighborhood. This neighborhood up here is the exact same as this neighborhood down here. So these guys correspond. Okay? So like this guy corresponds with this guy, and this guy corresponds with this guy. And they're all equal. And then you use the fact that a straight line, this straight line, is 180 degrees. It's half a circle. So you would subtract from 180, and you would get this other side, okay, which is vertically opposite here, which correspond down here. Okay? So this top right is equivalent to this top right, which is equivalent to this bottom left, which is equivalent to this bottom left. Okay? And that's a little review of junior high. A parallelogram, it's just a squished box, and it's not going to be too crucial for us. So that's brutal drawing. Let me just start over. You just draw parallel lines like this. A rhombus is that, but a square. So if all the sides are the same, like this, it's a rhombus. If you have two sets of like a rectangle, then it's parallelogram. But like I said, this kind of stuff, like it's not going to make or break us in trigonometry. Okay? And then we can move on to the next page. And this is some Pythagoras that we've already done. Okay. So let's move on to day 2, 2.1, the tan ratio. And this is what you have on your screen? Yeah? Or on your page is what you have? Okay. Yeah, this stuff is not gonna, let's just cross this out like this. We don't care about that. And I want you to, you guys got some blank space there? Perfect. Let's go like this. Labeling triangles. This is what I want you to put a new title, underline this, labeling triangles. And they have to be right triangles. So sketch in a right triangle. And you already know one of the labels. It starts with a H. Hypotenuse. So label your hypotenuse. Put in the little box as well, the little right angle box. Okay, so where's the hypotenuse? Good, across from the 90. So sketch in your hypotenuse. Good. Now there's only two other sides that are left to be labeled. Okay? And in trigonometry, these labels are absolutely critical. Okay? So we know our hypotenuse is straight across the 90. So you only have two labels that you need to know. So let's call this theta down here. Okay? If we're going to use theta down here, then you need two more labels. Opposite and adjacent. Okay? So opposite is straight across the angle. You intend to work with. So if you want to use that angle down in the corner, then you go straight across and label opposite. And some people do this at first to help them. Like straight across the 90 is the hypotenuse. Now those arrows are just in your mind to help you. So if you could label the hypotenuse and then find the angle you intend to work with and go straight across and label the opposite, then that last side is forced to be your adjacent. Okay? And adjacent means beside. Okay? So think about like your next door neighbor in your neighborhood, your house. Or maybe you live in a duplex. The place right next to you is adjacent to you, okay? Or maybe your house, your next door neighbor, that house is adjacent to you, but straight across, that house is opposite you. Okay? So across the street, that house is opposite to you. The house next door to you is adjacent. Okay? But take a look, this is kind of weird. If this is your angle, theta, you have two sides that are adjacent. Do you see that? Two sides are next to the angle. But one of them is the hype, right? The hypotenuse. So that has to be the adjacent. Okay? So it's the side that's next to the angle. That's not the hypotenuse. Okay, so the side next to the angle, not the hypotenuse. Okay? All right. And we're going to practice labeling today. And labeling is crucial to your success in trigonometry. Okay? So labeling is the first step to success. You have to be able to label a right triangle. Okay? The other little tidbit on this page that you should know is that the angles of a triangle add up to 180. Squares, parallelograms, and other four-sided closed figures have angles that add up to 360. So if I jot a triangle in, if this is 40 down here, what does this have to be? Because think about if all the angles add up to 180 and you have a 90 right there, so then you can just take away 90 right away. 180 take away 90 is 90. So then, good. These two these two angles have to add up to 90. The two acute angles sum to 90. Okay? So if that one's 40, this one has to be 50. Okay? Okay, next. Types of triangles. Okay. What types of triangles are there? Let's start with the one that has all the sides the same. What's that one called? Equilateral. If all the sides are the same, that must mean all the angles are the same. If all the angles add up to 180, then divide by 3 and all these angles add up to 60. Okay? So 60, 60, 60, always. Okay, those angles will always be 60, 60, 60. Now the next one, which I wanted to name my child, but the mother wouldn't let me. I wanted to name him Isosceles. Isosceles Lineweber. Sort of rolls off the tongue. Hey? That's a good childhood, right? I'm just kidding. I think that's a joke off of Seinfeld. Okay, so isosceles has only 2 sides that are the same. So boom, boom. So the 2 angles would be the same. The down in the corner, the 2 angles would be the same. So that's isosceles. That's when 2 sides are the same. And do you see these little ticks I put on the sides? What does that mean? That means they're the same. So if I put a double tick there, that means that one's different. Okay. Now what's the third type? Scalene. And this is when it's just really random and weird. That's when all 3 are different. So then all these angles will be different. So 3 different angles, 3 different sides. Isosceles, two congruent sides, 2 congruent angles, and then equilateral, 3 congruent angles, 3 congruent sides. And then the last one is the right triangle, which is what we're going to be focused on in trigonometry. That's where you have the 90-degree angle. Okay? And right angled triangles can be isosceles. They can be scalene, but they can't be equilateral. Okay, because equilaterals, they all have to be 60. Okay, and then it says at the bottom there, trigonometry is used for many jobs, and it's one of the most applicable mathematical disciplines that there are. So now we can talk about what you're going to do in Math 10C. In Math 10C, we will only study the right angle triangle of trig. Okay? In grade 11 and grade 12 or whatever, if you take Math 20 and Math 30, you'll learn that the trigonometry is actually the study of a circle, and that'll come in in the next couple courses. But in Math 10, we really just focus in on the right triangle so that you get a good foundation. Now all the triangles must be right angles, or we must be able to draw a right triangle to solve them. So in future studies we will learn trig ratios that use other types of triangles and other shapes like circles. Trigonometry, choosing the right ratio. Okay, so you have 3 buttons on your calculator that you're going to be using. SIN, COS, TAN. The first one is pronounced sine. This is apparently an abbreviation. They just took the E off. Okay, so the sine of an angle. The next one is called the cosine. So it's like sine. Here, I'll use the pointer. Look at the screen. I'll use the pointer. See this word sine? To see how it shows up again? Sine here. And then, but there's a word co in front of it. It's like the companion. It's like his friend. The companion to sine is the cosine. Okay? Do you see how they both work with the hypotenuse? One of them uses the label opposite, the other uses the label adjacent. So they're like brothers. Okay? One is the op brother, the other is the adjacent brother. And then there's this crazy sister on the side, the tangent. She's off on a tangent, okay? She does her own thing. She doesn't use the hypotenuse. She's different. So she does the ratio of opposite to adjacent. So trigonometry, all it is a connection between angles and ratios of sides in a right triangle. And that's all it is, okay? So these formula connect angles to ratios of sides in a right triangle. Because imagine if you had the distance from here to Jamaica, and then from Jamaica to England, and then back to where you were. That's a huge triangle, okay? You could do a little sketch on your paper with the exact same angles, and you can approximate distances, okay? So it's a very powerful mathematical tool, okay? And the triangle, you know, you could look up at the sun, or you could look up at the moon, figure out the angle. If you knew the distance, you could approximate things. Or if you knew the angle, you could approximate distances. Okay, so it's a very powerful tool. All right. And you should always make sure that your calculator is in degree mode. So everybody do that now. On the calculators that you borrow from me that are small, you're looking for this button, DRG. And you want your calculator to say DAG. That's if you have the scientific calculator like this. Scientific calculators, you're looking for a DEG at the top or a capital D for degree. If you have the TI, the big Texas Instruments calculator, you're looking to hit the mode button. Okay. Hit the mode button. And then once you've hit the mode button, mode is underneath alpha, no, besides second. See second in yellow? Mode is right next to it. And then you press down on the cursor again, and then you press over on the cursor, and then you hit enter. And you will highlight degree. And then to get out of that screen, hit second mode. See, second mode is quit. And then you get out of that screen. Okay? Now, just for practice, let's label this triangle up here. Okay? So let's use the angle down in the corner. Let's label this triangle. First of all, label the height. How do you do that? Find the 90 and go across. So there's the height. And then what I would do is next is find the op. So find theta. Go across. There's theta, go across. There's op. And then the last one is ADJ. It just has to go there. There's only one spot left. It's forced. That third spot is forced. Okay. The next thing. All trig ratios can be set up as a cross multiply and divide question. Highlight that. So that's lovely. Do you guys know how to cross multiply divide? Let's just quickly review cross multiply divide. A over B equals x over c. Let's say I wanted to solve for x. How would I do that? A times C divided by B. Why? The C just would have to come up here, right? So then you'd have CA over B equals X. Let's try another one. A over B equals C over X. What if I wanted to solve for X? How would I solve for this one? You always times the two that are across, and then you divide the thing across X. So the answer would be C times B over A equals X. And I'll go over that later as well. So if you're a little bit nervous, don't worry about that. We'll get to it later. Okay. So let's take a look at these questions. Let's just focus on labeling. Okay? So mark 23. And let's label that triangle. Where's the hype? Across from the 90. Hype is here. So what is 12? 12 is the op. So that forces A to be the adjacent. Oh no, this one looks weird. Theta's in a different spot. So this one's going to be a little bit different. Doesn't change the rules. So what is 24? Hype. Mark the angle that you're going to work with. 34. Go straight across 34. That makes this bottom side the op. And this one is the 80J. It's forced. So what's the difference here? What changed? The op changed. And the adj changed because the angle's changed. You're working with a different angle. Okay? If the triangle is in the same position, this triangle is identical to this triangle in terms of its dimension. Working with this one in the bottom right, here's op. If you're up here in the top left, then op's down here. So the op and the adjacent can change, but the hype always stays the same. Okay, next. Let's work at the bottom here. So for 16 degrees, X is the op, and 12 is the adjacent. And hype is always across the 90. So in this case, X is the hype, 19 is the op, and this is the adjacent. Now in trigonometry, what you have to do is you have to choose the appropriate ratio. You have to choose the appropriate ratio. And this is one of the hardest things for students at first, is choosing. So you have to label. First you label, and then 2 you choose. Now how do you choose? Well, we'll use this acronym to help us. SOHCAHTOA. And like if you talk to any person that's been through high school or your parents, if you just said SOHCAHTOA to them, they probably like, I know that. SOHCAHTOA is one of these things that everybody remembers. Okay? So sine does the O and the H. So sine does the O and the H. Remember, sine and cos are like brothers? Cos does the A and the H. So sine will do op and hype. Cos will do adj and hype. And then tangent, the sister's off on her own. She does op and adj, no hype. Okay? Okay? So for example, number 1 up top left here. They want to solve for A. So which do you choose? Which ratio would you choose? Do you see how I know nothing about the hype? I know 12 and I want A. I know 12 and I want A. And I know nothing about hype. Which one doesn't do hype? Yeah, so for this one, I'd use tan. Number one, I'd use tan. Because the formula for tan would set up a cross multiplication question where 12 would be the numerator and A would be the denominator, and then I could cross multiply. What about the second one here, top right? Which one would you use for that? Which side do I know nothing about? No, adjacent is a letter, so you want that one. You don't know nothing about op. So which one does adjacent x 24 hype? Cosine, good. So I would choose cosine for that one. Now 3 down in the bottom corner. Which one do I know nothing about? Hype. So then I'd use tan for that one. And then the last one in the bottom here. You know nothing about adjacent. You have op and you want hype, so this one would be sine. Don't say sin. You get hit in this class if you say sin. Seriously, you get hit. Then you go home and tell your parents you got hit. And they're like, why'd you get hit? Because I sinned. Uh-oh, somebody sinned. Pick a spot, mark it, and then put A next to it. And when that bell rings, you wait. Okay? So I need to go, which one goes 5 over? The bottom. 1, 2, 3, 4, 5. There's 5 because it's adjacent to A. Then I'll go 3 up. Come on, work. 1, 2, 3. There's 3. My hypotenuse would go straight across. Okay. And then I would go second function tan, 3 divided by 5, and it will spit out angle A for me. Okay? Have a good lunch. Have a good break. You can do B if you want. But in general, for the weekend, you are studying for measurement.